We have both graphs drawn. The original one is in red, that's f of x. And they tell us there's been vertical and or horizontal compressions that have happened. We need to write the equation of the image in terms of the function f. So this in terms of the function f means that you will have f of x somewhere in your equation on the right-hand side. So I'm going to show you two techniques for this question. I will show you the easy technique that works in this question, but only sometimes, and then a little bit harder technique that we're going to need to use later on. So first of all, the easy technique. What do we know the graphs are done? We sort of have to work backwards to get the equation. Usually you're given the equations and then you graph it. In fact, one of the things in mathematics that you have to do is you have to say to yourself, what usually happens and how do I do it? And now could I work myself backwards from there? So what usually happens is you have the equations. Then you would take points on your original equation. So I would have 3, 9 as a point on my original equation. I would have 2, negative 8 as a point on my original equation. And it looks like I have 0, 0 as another point on my original equation. And then you would draw your arrow. And above your arrow, you would write what you do from your equation. But since we don't have our equation, this is what we don't know. Finally, you would get your points, but we know the points. Where does 3, 9 go to? They've labeled it here for us. It goes to 1.5, 4.5. Where does 2, negative 8? That's the minimum right here. Where does it end up? It ends up at 1, negative 4. And 0, 0 happen to stay the same. So we know where the points started, and we know where they ended. Can you look at your values? Can you tell me a way to get from 3 to 1.5, 2 to 1, and 0 to 0? Can you look at your y coordinates and come up with a way to get from 9 to 4.5, negative 8 to negative 4, and 0 has to stay at 0? What's happened? What do we have to multiply our y values by? 1 over 2. Can you see they've each been cut in half? What would you have to multiply your x values by? Also 1 over 2. So you see how we're working backwards? Normally we would have been writing that first and then finding out the points. This time we have the points, and we can find out what we needed to multiply by. As a result, how would this have showed up in the equation? What affects the y happens outside of the function. What affects the x happens inside the function. So if I want to multiply y by a half, I would need a half outside of my function. And if I want my x values to get multiplied by a half, I would need a 2 inside my function. And so what we have here as an equation is in terms of the function f, because on the right-hand side of the equation, we've included f as function notation. So whenever an equation says, and you will get this quite often, in terms of, sometimes it says in terms of f, then you need to have the equation f on your right-hand side somewhere. Sometimes it just says in terms of x. Then they want the actual equation just with x's. So this is the best way to do this question. What I'm going to do right now is introduce another method for looking at it that's going to be helpful, especially when we get to 3.4 and 3.5, when we get more complicated ones. Because eventually what's going to happen is we're going to put our stretches and compressions with our translations together. And it won't be easy to see what happens when you go from your first point to your end point, because too many calculations could happen and you could make mistakes. And it's just harder to find out. So this next technique won't be as intuitive right now, but it will be helpful later on. Okay, so we'll label it as method 2. And method 2 analyzes both functions to figure out the stretches and the compressions. First of all, to figure out what happened horizontally, we can label as horizontal distances, and you need to choose 2 points on your original graph and their corresponding points on your image graph. So on my original graph, I'm going to label this as point A and this as point B. And the way we label corresponding points on an image graph, same letter, but we put a little, it's called a prime mark, A prime, a little dash up there to say that that A went with that A, and this point here will be B prime. And then you say, what happens if I go from A to B? If I just think about my horizontal distance. Well, my point A is at 3. My point B is at 2. Notice how I'm just looking at my x values. I would have to go back 1. So I would say from A to B is -1. I then compare the same thing. Ooh. Whoa, wait for it. Sorry, that was my red function, so I'm going to change it to red, just to keep things matching up. So from A to B, it was -1, and then I go to my blue graph, and I do the same thing and see, well, what happened when I went from A prime to B prime? So I go back up to my graph, and I say if I started here and ended here, I would have to go back a half. How do you get from -1 to -1/2? What would you have to multiply x by? To do that, you would have to multiply x by 1/2. If the original horizontal distance was -1, and now it's -1/2, you would have to multiply by 1/2. Now, some of you might be wondering, Mr. JR, why didn't you just say that the horizontal distance between them was 1, and the horizontal distance here was 1/2? You would get the same thing. Yes, that's true. However, sometimes there's reflections. Sometimes there's reflections that take place, so the distance and the direction you travel is important. So if I chose that one as my A and B, and going from A to B went backwards, I need to label that as a negative. But it still shows up that x gets multiplied by 1/2, right? Is that way more complicated than what we did to begin with? Yes. Could you see that it was 1/2 quite easily? Yes. So when it's something simple with just one transformation, as in this example, for sure, do the first method. But the second method will be helpful when we get into the more complicated ones. So with the second method, we figured out what we need to do with our x's. Now we're going to do the same thing with our y's, we look at, on our red graph, what happens when you go from A to B? Well, with our y values, we started at 9. We ended up at -8. Going from A to B would make me go down 17. So since I'm going down, I'd label that with a negative. Next, I go to my blue graph, and I check what happens when I went from A prime to B prime. Well, I started at 4.5. I ended at -4. I'm going down again. How do I get from there to there? What would I multiply my y value to do that? Again, my y value is multiplied by a half. So that's a little bit more complicated, right? For the examples that you're going to do to practice right now, 5, 12, 13, and 14. For those examples, you can just use the first technique, draw the points and where they end up, and figure out what had to happen at the arrow to make that happen. Will work out just fine. But method 2 we're going to need later on, so when I teach it to you again later, it'll be like, oh, I've seen this once already, and hopefully it makes more sense the second time.